Hello friends, I welcome you all in this session. As you are aware, in previous session we were discussing about chi-square test and we have seen chi-square test of independence, wherein we have worked out several questions. In today's session I am going to talk about regression, simple linear regression. So, whenever we talk about regression, we always talk about correlation as well. In fact, regression and correlation go hand in hand. We have seen correlation when we talked about the measures of dispersion, where we have seen there is something called coefficient of variation, right. So, apart from coefficient of variation, there were other measures of dispersion which we have seen, but in today's class we will look at regression. So, what is regression? In simple term, regression is something which gives us association between two sets of numerical data or two time series data. So, you can have an association between, let us say, age and weight, or let us say you can have relationship between expenditure and income, higher the income, higher the expenditure, right. So, you can have this sort of relationship. So, relationship can be either positive or negative, or you may have a situation of no relationship at all, right. So, regression is something which gives you association between two variables which are measured on metric scale. So, if you want to know association between any two variables, then the best thing is you should plot something called scatter plot. So, it gives you an idea about association between two variables. Correlation is something which measures how strong that association is. So, it measures degree of relationship between two variables, and it measures only a linear relationship. We are not talking about non-linear relationship. So, how the strength of association is gets measured by correlation. It has nothing to do with causation, right. Keep in mind, correlation has nothing to do with causation. When I say causation, means there is something called cause and effect relationship. So, we are saying that let us say there is high correlation between income and expenditure, but it does not mean that there is income and the cause is expenditure. It is not like that, right. So, correlation has nothing to do anything with causation. So, regression analysis has got two important functions, two important applications. Either it can be used for prediction or it can be used for explanation. So, prediction function and explanation function are the two functions of regression. So, when I say prediction function, it means it predicts dependent variable. Let us say profit is a function of sales. So, profit is dependent variable, sales is independent variable. So, if we have sales data, we can perform experiment on let us say independent variable by increasing or decreasing sales, and we will see the effect of that experiment on profit, right. It explains the impact of change in independent variable on the dependent. So, the second function is explanation function, right. It will help you in knowing how much change in dependent variable occur if there is a change in independent variable. So, in regression you will always have at least one dependent variable and one independent variable. So, if there is a dependent variable and an independent variable, it would be a simple regression. It is a bivariate regression. You may have multiple regression as well, wherein you can have more than one independent variables, right. So, dependent variable is something which we wish to predict or explain, right. As I said, profit is a function of sales. So, sales is independent variable and profit is dependent variable. Independent variable is something which we always use to predict or explain the dependent variable, right. So, when we talk about simple linear regression model, we will have just one independent variable and the relationship would be a linear between x and y. So, x is independent and y is dependent variable. So, change in y are assumed to be related to changes in x. Okay. So, whenever there is one unit change in independent variable causes one unit change in dependent variable, then it would be a perfect linear regression model, right. Let us look at couple of relationships. So, you have got independent variable over here on x axis. So, independent variable x is independent variable, this is dependent variable, right, on y axis. So, you can just simply write an equation y is equal to, let it be like the mx plus c, right, is nothing but equation of line, right. So, here c is constant, right, m is the slope and x is the independent variable, right. So, there is a linear relationship, there is a positive linear relationship. The moment we increase x, the value of y also increases. So, this is linear relationship. So, linear relationship can be positive or negative. Now, this is a negative one, right. So, the moment you increase, let us say x, the value of y decreases, is not it. So, this is a negative relationship, but linear, right. You may have a situation where relationship is curvilinear, but in most of the times you will have curvilinear relationship, right. So, this is how the value of y is changing with respect to x. So, when x increases, value of y increases, but after a particular point, let us say after this, if you further increase value of x, then y starts decreasing, right. This is a kind of exponential relationship, right. So, with increase in x, the value of y is increasing, but the rate of increment of y is more in this case compared to this case, is not it. So, these are couple of relationships. So, you can have strong relationship. So, with increase in x, y is increasing, but this relationship is positive and strong relationship. Why we are calling it strong relationship? Because this dispersion or this standard deviation is very less compared to this standard deviation, is not it. So, if standard deviation is less, it would be a stronger relationship. This is again strong relationship, but negative one. So, this is positive one, this is negative one, and again weak relationship, positive and negative, right. You can have a situation of no relationship at all. So, x and y are independent, they are not related to each other, a situation like this. Okay. So, there is no relationship. So, we have seen linear relationship, curvilinear relationship and no relationship. So, this is how the simple linear regression model looks like. So, this is y is equal to or yi is equal to is b0 plus b1 x xi plus minus error ei. So, this is your dependent variable, this is intercept. Intercept is something which you will get if you keep x is equal to 0 in this equation. So, for a 0 value of x, whatever is b0 is nothing but intercept. So, this is your independent variable, population slope coefficient, right. So, this is coefficient of independent variable x1, you can call it, you can have different multiple independent variables, right. So, this is linear component of the relationship and this is error component, right. Simple linear regression model will continue this model. So, yi is equal to, this is slope, this is intercept, right, b0, this one, b1 is slope, which is this one, this angle is nothing but bi, right, this is bi, right. xi is, you can have more than one independent variables, right, and this is nothing but error term. So, let us say you have got these, let us say 4 data points, right, and let us say this is the line passing through these 4 data points, right. So, this is predicted value of y for given xi value. So, the value of y is this for a given value of x. If you look at this particular point, for this particular point which is at x1, let us call it x1, or let us say let it be 3 for simplicity. If it is 3, then there is some value of y, let us say 10, then this is the error term in it and this is explained variance, this is known as unexplained variance and this is known as total variance, right. So, you have got error term. Now, keep in mind this error term is plus and minus both, it is you cannot have just positive error, error can be negative as well, right, just see here, right. So, always keep in mind that the error term will be positive and negative both. Now, let us talk about prediction line, the line which will predict the value of dependent variable for a given value of independent variable. So, this is y hat. So, estimated y value for observation I, right. This is again intercept b0, this b1 and this is independent variable xi, right. So, this is simple linear regression equation provide an estimate of the population regression line, right. So, this is estimation equation. You can draw a line which is which will call it line of best fit passing through several data points, right. In fact, you can think of this line as a line of best fit, right. So, this line of best fit can be drawn. So, the least square method is this. So, you can have b0 and b1 are obtained by finding the values that minimizes the sum of the square differences between y and y hat, right. So, this is the estimated value of y and this is given value of y. So, we want to minimize the sum of squared differences, right. Just see, this is sum of squared and difference and this is how you can minimize it. So, the coefficients b0 and b1 and other regression results will be found using XLR Minitab, or in fact there are formulae available for finding b0 and b1, but you can always use a software, maybe SPSS, SAS or let us say Minitab or any other statistical software. How to interpret slope and the intercept. So, as I said, b0 is the value of y when x is equal to 0, right. As I said, y is equal to mx plus c. So, if I keep x is equal to 0, then this becomes y is equal to c. So, this becomes b0, right, which is this, right. b1 is the estimate change in the mean value of y as a result of 1 unit change in x. So, if you change independent variable x1, let us say there is only one independent variable x. If you change its value by 1 unit, then the change in value of y will be given by b1, which is known as coefficient of independent variable. So, let us solve a question. A real estate agent wishes to examine the relationship between selling price of a home and its size. So, size is measured in terms of square feet and selling price is measured in terms of dollars. So, independent variable is size of the plot and dependent variable is price. So, the state agent wishes to examine a relationship. So, is there any relationship between these two? So, some data were collected on house price and square feet, the size of the plot. So, this is your independent variable and this is dependent variable. So, when size is 1400 square feet, price is this much 245,000, right. For simplicity we are not writing 0 0 and 0 here, right. So, when size is this, price is this, when size is this, price is this. So, we want to know, is there any relationship between these two. So, for that, first of all, you can get an idea whether there is any relationship exists between two variables or not just by drawing scatter plot. So, draw a scatter plot first of all. So, if you look at scatter plot where this is your x independent variable and this is y which is dependent variable, house price, right. So, you can see that when this is the size, this is the price, when this is the size, this is the price, when this is the size, this is the price, right. So, if you look at this, there is some trend which is in positive direction, is not it. We do not know whether this relationship is strong or weak, but it seems that there is some positive relationship, right, because as you increase size of the plot, the house price increases. So, there is some positive relationship. So, how to check that positive relationship? Let us look at this question. So, you can solve this question using just Excel. So, you have got house price which is y dependent variable and x is size of the plot, right, square feet. So, you can just give input as y is equal to this and x is equal to this, right. After that you just click at OK, you will get output. So, this is the output of Excel. So, if you look at output, it has got 3 different parts. This is the first part of the table, this second part and this third part, right. So, the first part you are getting regression statistics. So, regression statistics is, in fact, you need to remember R square and adjust R square and standard error, right. So, we will say that if you look at intercept over here, so intercept is this 98.23 plus this is your coefficient, right. This is coefficient and this is your independent variable and this is your y value. So, house price is equal to 98.24 plus 0.109 square feet. So, this is our regression equation, right, and we have got one more information over here. So, R square is this 58.0 58.082 percentage, right. So, in other words we can say, yeah, it is 58.008, right, percentage. So, we will say that the variation in dependent variable or this much variance in dependent variable is explained by independent variable plot size, right, and this is error. So, we will say that this is explained variance, this is unexplained variance, and if you add these two it should be total variance, right. So, look at regression statistics, especially R square, adjusted R square and standard error, and you will get coefficients and over here intercept and the coefficient of independent variable, right. You will get ANOVA table as well, which will tell you how good this model is, right. So, for the time being, in fact, you can skip this part of the table, but keep in mind the lowest portion of the table and this part, right. So, this is output from Excel. You will get almost similar output from Minitab. So, you will get the same coefficients, right. So, just see this 98.25, this is coefficient of independent variable 0.10977 square feet, and if you look at R square, which is 58.1%, is not it, and standard error is this much. So, we should have a model in such a way that the R square should approach towards 100% and standard error should be as low as possible. Of course, ANOVA table is again available here. So, we will say that when we say this regression P is 0.01. So, we will say that there is a significant relationship between independent variable and dependent variable. In fact, you can always frame a null hypothesis that there is no association. So, H naught will be no association between dependent and independent variables. So, alternative hypothesis, there is association. So, you are rejecting null hypothesis, it means there is association, right. So, this is your scatter plot and this is your line of best fit which you have just calculated, right. This is nothing but your line of best fit, right. So, this is how this line is passing from here. So, slope is given, intercept is this 98.2, just see this value, this is 98.24, it is not exactly 100. Okay. So, if you have got this equation, then you can find out house price for a given value of square feet. Okay. Let us look at interpretation of this B0 once again. So, B0 is something when you put square feet is equal to 0, right. So, B0 is estimated when mean value of y when the value of x is 0. So, if x is equal to 0 in the range of observed value of x. So, if you put this is equal to 0, this is nothing but B0 value. So, because a house cannot have a square footage of 0, B0 has no practical implication as far as this question is concerned. Let us look at how to interpret B1, which is the coefficient of independent variable. So, B1 is equal to this, right. It tells us that the mean value of house increased by this much rupees or this much dollars, right. If we increase size of the plot by 1 square foot. This is the meaning of B1. So, let us say if you want to predict the price for a house with size this much, 2000 square feet. So, just put over here 2000 in this equation. So, the house price would be this much dollars, right. So, you can find out price of house for any given size of the plot. Now, it is always suggested to predict in such a way that the value of x should not beyond this limit, it should not go beyond these two limits, otherwise there would be more and more chances of error. So, we should always predict within the relevant range of data, and this is nothing but relevant range of data. How did you get this? This is the minimum and maximum value of x. So, if you look at this, the maximum value of x is somewhere here, right, this one, right, this is something 2450, right, this point, this line, and the lowest is approximately this one, right, it is 1100, right. So, it is always suggested that you should find out the house price for any given value in this area, right. Do not try to extrapolate beyond this limit or interpolate below this limit. Okay. So, do not try to extrapolate beyond the range of observed axis. Why? You can always extrapolate or interpolate, there is nothing wrong with this equation, but only the point is the error term would be higher in that case. So, try to predict in relevant range of data. So, let us look at how to solve this question using Minitab, right. So, this is the question, right, and let us solve this question using Minitab. So, house price is dependent variable and square feet is independent variable. So, 245. So, first of all you should enter all data points of first series, right, it is called house price. Second series is size of the plot in terms of square feet. So, you have got in fact this is the sample data, right. So, sample size is 10 over here. So, 1875 1100 1550 2350 2450 1425 and 1700. So, you have got this dependent variable and this one is independent variable, right. So, go to state, just go to regression, then just go to simple regression, right, regression, then fit regression model, right. So, here response variable is C1, right, house price is response variable and predictor variable is square feet, right. In fact, if either you call it independent variable or predictor variable, one and the same thing, right. So, in fact, you can have a situation where independent variable may be categorical as well, right. So, we will work out examples when your independent variable is categorical. So, just click OK. Yeah. So, let us look at just compare the output of what we have seen with this output. So, if you look at r square, first of all is this, just see this, it is 58.08, while in our case what it was also 58.08, same value, same answer, right, from Excel output. Let us compare it with Minitab output, right. So, this was 58.1%, right, it is close to 58.08, right. What about standard error? Standard error is 41.33, here it is 41.33, right, same. If you look at the p value of a square footage, square feet, it's 0.010, right. Let us look at this. So, for this is the value, p value for square feet for independent variable. It means this is a significant independent variable, while for constant if you look at this 0.129. So, this is insignificant, right. So, this is how you can solve a question on regression using Minitab software. In next class we will see some more examples on regression, and we will take couple of examples on multiple regression as well. So, with this I complete my session over here. Thank you very much.